So now that we've covered the big picture view of the fork join framework, talking about the fork join pool and the fork join task and the subclasses of fork join task, it's time to start zooming in a little bit on some of the key methods in these classes so we really see how to program them. And we'll start out by talking about key methods in fork join pool. So the fork join pool class extends the abstract executor service class. If you take a look at the Java doc, or you just take a look at the source code, you'll see that that's what it does. And therefore, of course, because of the magic of object-oriented programming, it implements a bunch of the methods defined in executor service, things like execute, submit, invoke all, invoke any, and so on. So execute, as I'm sure you know by now, arranges the async execution of a one-way task. Submit arranges to have the execution of two-way async tasks and returns a future. Invoke all will run a whole bunch of tasks in a collection and wait for all of them to finish. And then invoke any will invoke a bunch of tasks and wait for the first one to finish and cancel the others. So those are things you get kind of because of the fact that we are an executor service implementation. However, nobody in their right mind would use these methods in general for a fork join pool, although, as it turns out, for our simple use in Programming Assignment 4A, we will in fact use execute, but that's not the beauty of fork join. Instead, what you want to do is you want to use mostly, or typically, these other methods that will execute, invoke, and submit fork join tasks. And those are much more powerful and really leverage the real beauty of this framework in a more grand way. And as we talked about before, as you can see here, the clients can invoke these methods and they store the fork join tasks that are passed in a shared queue, and then threads inside the fork join pool will pull the fork join tasks off the shared queue and then start the whole process of running them in the context of the work stealing fork join pool semantic mechanisms. And of course, because of this, these methods can leverage the very powerful properties of the fork join pool. So first is the execute method that arranges the async execution of a one-way task, and it will perform the task, invoke performs a two-way task, blocking until the task is done. So that basically is like a two-way synchronous call. And then the third method, submit, will submit a fork join task that will run asynchronously, and it returns a future, and that future is a fork join task. And as if you were to look very carefully, you would see that fork join task ultimately implements the future interface. So it gets all the methods from future as well. Now, by default, if you make yourself a new fork join pool object, the size of that object defaults to the number of cores available to the Java runtime. So if you take a look here, you can see fork join pool, and it's going to go ahead and create a fork join pool that will have a size, where size is the number of threads, that's equal to the underlying execution environment's knowledge of the number of available cores. And it's also, just as a little side note, it's important to realize these are virtual cores. So for example, on my 8-core machine that I'm running on right now, each of those cores is hyper-threaded. So the get runtime available processors method actually returns 16 cores, even though I only have 8 cores. There are 8 hyper-threaded cores. And then you can also, if you don't want the default, if you want to, say, restrict the number of threads to be smaller than the number of cores, you can pass in a parameter to an alternative constructor for fork join pool, and then you can set the parallelism level that way, which could either be less than or greater than the number of cores that is known by the platform. There's also something called a common fork join pool. And interestingly enough, that's actually the most common, hence the name, way of being able to have a fork join pool. And you can access the common fork join pool by invoking a method which has the name common pool, and that is a static method. So you can say fork join pool dot common pool, and you can access the common fork join pool. And that particular method means that any thread in a process can get access to the common fork join pool. Now, what is the common fork join pool? The common fork join pool is most commonly used by any fork join task or any program that wants to submit fork join task that is not trying to submit the task to a designated or specified pool. So it's the common pool. So it's the one that's shared by everybody if they don't want to go to the trouble of making their own. And there's actually a really good reason to have a common fork join pool. And that's because if you submit all your tasks to the common fork join pool, then the underlying fork join algorithm with its cool work stealing behavior can optimize and maximize utilization of the underlying processor cores because it has a global view of all the things that are running on the platform. There's also a bunch of other kind of convenience methods that will provide management capabilities and monitor various things. So you can see here, you can get the target parallelism level of a given pool by calling get parallelism. You can get the size of the pool. You can get the number of tasks that have been submitted that have not yet started to run. You can find out how many steals occur with work stealing. We're going to use this method later to see the difference between different algorithms that use fork join pool in different ways. And in a general sense, work stealing has pros and cons. The main thing it'll do is over time, if you allow work stealing to happen, you can end up with much better scalability. But of course, there's some overhead from doing this as well. So you have to have a good understanding of what's happening under the hood to know what the right programming model is. So those are just the four methods. So that's a quick overview of the key methods in ForkJoinPool. By far, the most important ones are execute, invoke, and submit. And those are the ones that are used to actually provide fork join tasks that will run in the context of the fork join pool.